Did you know that if you were standing on Mars right now, your blood would start boiling in just 15 seconds? And if you traveled to Venus, the atmospheric pressure there is so intense that you would be crushed instantly. But here's the most fascinating part. NASA scientists have already developed technologies that could help humans survive on these alien worlds. Imagine if I told you that we've been continuously living 400 kilometers above Earth on a space station for 25 years. And now scientists are planning the next step: permanent settlements on other planets. But how realistic is this dream? Hello everyone. Today we're going to talk about a topic that sounds like science fiction, but is actually pure science. Space survival and human adaptation to alien worlds. This isn't just happening in movies. It's happening in real life. Astronauts on the International Space Station have shown us that humans can adapt to space, but the challenges are enormous. Radiation exposure, bone density loss, muscle atrophy, psychological isolation. These are all real problems that space travelers face. Today, we'll learn how humans have developed technologies to survive in space, what planning is underway for colonies on Mars and the Moon, and most importantly, can we actually settle permanently on other planets? At the end, we'll discuss how realistic these plans are and what challenges remain unsolved. The concept of space survival became serious in 1957 with the launch of Sputnik 1. But the real journey of human space survival began in 1961 with Yuri Gagarin. He was the first human to go to space and return safely in the 1960s and 70s. NASA achieved moon landings through the Apollo missions. Neil Armstrong and Buzz Aldrin showed in 1969 that humans could survive in alien environments, even if only for a few hours. They wore special spacesuits that protected them from radiation and temperature extremes. The real breakthrough came in 1971 when the Soviet Union launched Soyuz 1, the first space station. This helped scientists understand that long-duration space survival was possible. In 1973, America launched Skylab, where astronauts stayed for 84 days. The biggest milestone came in 1998, when construction of the International Space Station began. Since November 2000, humans have been continuously living on the ISS. That's 25 years of continuous human presence in space. Scott Kelly spent 340 days on the ISS. Christina Koch spent 328 days. These records show that humans are capable of long-term space survival. Russian cosmonauts have gained the most experience. Valery Polyakov spent 437 days on the Mir space station. This is still the record for a single spaceflight, but the real test of alien world survival began in 2021 when NASA sent the Perseverance rover to Mars. Along with it went the MOXIE experiment, which can produce oxygen from Mars' atmosphere. This was the first time anyone had created oxygen on another planet. China has also entered the space race. In 2021, they launched the Tiangong space station and landed the Zhurong rover on Mars. India has also entered Mars exploration with the Mangalyaan mission. The biggest mystery in space survival is how the human body adapts to space environments, and whether this adaptation can be permanent. The data scientists have gathered from the ISS is both contradictory and concerning. The problems astronauts face in space are shocking. Due to microgravity, bone density reduces by 1 to 2% every month. Muscle mass decreases by up to 20% in just a few months. The cardiovascular system weakens because the heart doesn't have to pump against gravity. The most mysterious aspect is radiation exposure. Cosmic radiation levels in space are 100 times higher than on Earth. According to NASA, astronauts going on Mars missions face a 3% increased cancer risk. But these calculations are based on Earth-based studies. What actually happens in space is still unknown. Psychological effects are even more concerning. Astronauts report the overview effect. Their worldview completely changes after seeing Earth from space. But there are also negative effects of isolation and confinement. Some astronauts have reported depression and anxiety after long-duration missions. Major mystery in Mars exploration is terraforming. Scientists claim that Mars can be made Earth-like by releasing greenhouse gases. But critics argue that Mars has no magnetic field, so the atmosphere would escape. Elon Musk suggests using nuclear bombs to melt Mars' polar ice caps. But experts consider this dangerous and impractical. There are also conflicts regarding moon colonies. NASA's Artemis program claims a lunar base will be established by 2028, but the technical challenges are immense. Lunar dust is toxic. Temperature variations are extreme from minus 173 degrees Celsius to plus 127 degrees Celsius. And radiation shielding is a major problem. Private company claims are even more controversial. SpaceX promises to send humans to Mars by 2029. Blue Origin is about to start lunar tourism, but their safety records and technical readiness raise questions. The biggest mystery is whether humans can actually become a multi-planetary species, or if this will remain limited to temporary exploration. Scientists have mixed evidence about space survival. Looking at positive evidence, the International Space Station's successful 25-year operation proves that humans can survive in space for extended periods. NASA's twin study showed remarkable results. Scott Kelly was in space for 340 days, while his identical twin Mark stayed on Earth. Results show that Scott's gene expression changed. Telomere length increased and gut microbiome altered. Interestingly, most changes reverted after returning to Earth, but some remained permanent. Medical evidence suggests the human body is surprisingly adaptable. Astronauts develop better spatial awareness, enhanced problem-solving skills, and improved hand-eye coordination in microgravity. Bone loss is reversible with proper exercise and nutrition. Technological advancement is also encouraging. Developed the Advanced Closed Loop system that achieves a 93% water recovery rate on the ISS. The MOXIE experiment successfully produced oxygen from Mars' atmosphere. 3D printing technology has been successful in making tools and spare parts in space, but there's contradictory evidence too. Long-term studies show that some astronauts develop vision problems, sans spaceflight-associated neuroocular syndrome. This condition can be permanent and affect mission-critical task performance. Radiation exposure theories are divided. Conservative estimates suggest that Mars mission astronauts will remain within acceptable risk ranges. But recent studies were underestimating the cognitive effects of cosmic radiation. Mouse studies show memory impairment and anxiety-like behavior after space radiation exposure. Psychological adaptation theories are also complex. Some experts argue that humans are natural explorers and can thrive in space environments. Antarctica. Research station data supports long-term isolation survival, but critics point out that rescue is possible from Antarctica, not from space. Terraforming. Theories range from conservative to radical. Mainstream scientists suggest gradual atmospheric modification through controlled greenhouse gas release. Radical approaches include solar mirrors, atmospheric processors, and genetic modification of plants for space conditions. Resource utilization evidence is promising. Water ice has been confirmed on the moon in polar regions. Nita deposits and subsurface water distance have been proven on Mars. These resources can be used for life support and fuel production, so everyone, space, survival, and human adaptation. Two alien worlds is a fascinating topic that's transforming from science fiction to reality. We've seen that humans have been successfully surviving in space for 25 years, and technology continues to improve. Key takeaways are: the human body can adapt to space, but the challenges are serious. Radiation exposure, bone loss, psychological effects, all of these are manageable with proper planning. Mars and moon colonies are technically possible, but timelines need to be realistic. The most important question is, will humans become a multi-planetary species or remain Earthbound? The evidence is mixed, but the direction is clear. We're investing in space exploration. Let me know in the comments, would you want to live in a space colony? Do you think permanent settlement on Mars is possible by 2050? In the next episode, we'll discuss the search for extraterrestrial intelligence. Do aliens exist? And can we contact them? This topic is even more mind-blowing. If you found this video helpful, don't forget to like it and subscribe to the channel for future episodes. If you want to learn more about space exploration, related videos are linked in the description